Welcome. In this video, we're going to play a game of ping pong, at least in the abstract. And the game is going to be introduced in the form of an interview, where I'm kind of interviewing myself, but I'm going to look at some constraints set out in a main.go file, and hopefully at the end I've explained some of the concepts, worked through, satisfied the requirements, and given you an opportunity to learn something along the way. Because at the end of the day, one of my primary objectives is to spread some of the knowledge that I've gleaned over the years. All right, let's take a look at the code, or the requirements, and then we'll write some code. Let's play a game of ping pong. Fire off two functions in the background that toss a ball, an integer, back and forth until one of the players randomly misses. All right, the table here is a channel, or will be a channel, and I'm actually gonna go ahead and create it now. So I'm gonna use the make keyword. This is a channel of type int. I could supply another argument here, but I think in this instance, an unbuffered channel makes way more sense than a buffered channel because we want that signaling guarantee. In fact, maybe we can create another file here in a minute where we essentially illustrate the guarantee that you get. In fact, there has to be a receiver in order for a send to even take place. Let me back up real quick before I'll just copy this out. It might be cool. It might be cool to take all this and put it into a playground link or a playground link. So let's see here. And there's the better Go playground. Let's use it. Throw this in. All right, I'll click on share, copy link, and let's go to the README file. Play along. All right. Problem. Right, and when we're done, I'll add the solution. Back to the code. So let's throw in the table. I lost it. Table, make, channel type int. Again, this is an unbuffered channel for the signaling guarantee. A buffered channel is more like I have lots of things to do, and it's okay to queue those things up. All right. Use a counter-like object to ensure the players get a chance to play. Counter-like object. Well, this is a semaphore. And since there are two players, I'm going to go ahead and add two. This is kind of like a stack, right? So down at the bottom here, it says wait for the game to end. Well, this essentially will block until we've removed the two that we added here to the stack. Okay, send the players to the table. Then we're just going to call player here, but I'm going to use an anonymous function to do so. And there's the syntax for that. And let me go ahead and put the signature in here so this doesn't look as weird. So write a function allowing players to hit the ball back and forth. Well, we want to print out who's hitting the ball or who won or who lost. Name's going to be a string. The other thing we pass in is a table, which is a channel of type int. Now here, we'll just have Mario play Luigi. Mario and the table. Inside of this anonymous function, I'm going to go ahead and call done, not add. All right, done. So as soon as this returns, either we close the channel or something else happens, we'll call done. This will decrement add. So here it will go down to 1. The next one will go down to 0. This unblocks, and we finish the execution of our program. I'm going to duplicate this line. Mario is going to play Luigi. I wonder who's going to win. Toss the ball onto the table. I'm going to set a variable to 1, and then table, let's throw the ball. Okay, let's go ahead and implement player. This is going to be a for loop, or this will be a for loop. Let's move these comments into here. The ball comes across the table. I'm just going to call this ball, why not, and play. Channels actually return 2 values, and let's see, we want to receive. The second value, play there, is whether or not the channel is closed. So I'm going to say if not play, so if we're no longer in play, i.e. the channel is closed, we're going to say that the player won. Okay, because down here we'll have the player miss, which means the next time this gets called, that's the winning player. And instead of using println, we'll use printf. So player s1. Let me add a new line character and name. Okay, so when the formatter here, whenever it gets rendered, name gets tossed in there. And if that's the case, we want to return. randomly in the game. Okay, maybe we'll set a global variable in, and we'll call the rand package. How about any integer up to 100? Oops, wrong syntax there. You can only use the short declarator inside of a function. All right, randomly in the game. All right, how about if the ball is equal to n, game's over. And I'm gonna duplicate this, just because I don't feel like typing all that much. Instead of player 1, player missed. Okay, and we're not just going to return, we're also going to close that channel. So we're going to call close on table. Otherwise, we hit the ball back. So let's add a print statement here. Print. Again, we actually want to use printf for formatting. And we'll say player at s hit d, new line, name and ball. We'll go ahead and increment ball. And at this point, we send it back over the table. All right, so into table, ball. I think that covers it. All right, we've got our blocking operation. We have our functions fired off in the background. Let's run it and see who wins. Okay, go run dot. Luigi won because Mario missed 57 hits. How about let's run it again. Oh, quick game. Luigi hit it across the table. Mario immediately missed and Luigi won. So Luigi won 2. Let's play it one more time. Ah, there we go. Mario wins. All right, let me take this solution. And let's go back to the playground. We can use this same bit. I'm gonna click share, copy link. I will add both the problem and the solution links into the description of the video. Let's see, solution. It's great to go through these videos and watch someone else explain something. I think it's also advantageous to experiment. You know, pull down the problem, see if you can solve it. And if you can't, look at the solution, write the code out to solve it. It's through experimentation and doing that we actually retain information. I think that does it for now. Well, if you have any questions, throw them in the comments. Otherwise, thank you all for watching. Have a great day.